They know they saw something. They followed it. They locked their radar on it. There is very likely to be life.
For many years, we've lived to question our existence, whether we're alone or if there could be other forms of life. Well, since we're so young in the universe, it's accurate to assume that if there could be other forms of life, they would be too intelligent, with millions of years of knowledge. If this was true then, and they happened to know about us, we would be very much insignificant. Sort of how we view flies or ants, smaller life forms that don't really deserve our attention, but we sometimes are interested in their actions. Could this be the case, and are we being observed? Well, stick around till the end as we dive deeper into today's concern. On October 19, 2017, astronomers detected the first interstellar object passing through our solar system. This object, designated Oumuamua, perplexed astronomers who couldn't figure out whether it was an interstellar comet or an asteroid. After 4 years and numerous theories, including the contentious ET solar sail hypothesis, the astronomical community reached a conclusion that explained all of the observations. According to the nitrogen iceberg theory, Oumuamua was most likely debris from a Pluto-like planet in another solar system. Amir Siraj and Professor Avi Loeb, who proposed the ET solar sail hypothesis, provided an official counter-argument to this theory in their latest study, titled The Mass Budget Necessary to Explain Oumuamua as a Nitrogen Iceberg. According to their paper, there aren't enough exoplutos in the galaxy to explain the discovery of a nitrogen iceberg. Loeb indicated in the paper where he first brought up the idea that Oumuamua's peculiar personality and behavior were consistent with a solar sail. This included the fact that the object had a highly reflective quality, which gave the impression of being either cigar-shaped or pancake-like. More importantly, its sudden acceleration and deviation from its expected orbit seemed to be the result of radiation pressure, which is precisely how solar sails achieve propulsion because it's the driving force behind the sails. Additionally, there was the manner in which it entered our solar system, which enabled it to perform a flyby of the Earth after coming to its closest approach to our star. Basically, the dynamics of its orbit made it possible for it to get an up-close look at the only habitable planet in our solar system, which is precisely what one would anticipate from an alien ship. These arguments were discussed in greater depth in Loeb's book, Extraterrestrial: The First Sign of Intelligent Life Beyond Earth. At the time this book was being written, all of the attempts made to explain Oumuamua in terms of natural phenomena were unsuccessful. Because there was no evidence of outgassing, there was not a single explanation that could account for its brightness, profile, or even acceleration. In addition, the sudden acceleration couldn't have been caused by gravitational forces because those should have been slowing Oumuamua down at the time it was observed to be accelerating. Two researchers working in the School of Earth and Space Exploration at Arizona State University presented a novel theory in March of 2021. SESC Exploration Fellow Alan Jackson and Professor Stephen Desch argued that Oumuamua may have been a fragment of nitrogen ice that was ejected from a young star system approximately 400 to 500 million years ago, possibly in the Perseus arm of our galaxy. Jackson and Desch addressed the size and composition constraints of Oumuamua in their first paper together. They also demonstrated how Oumuamua's reflectivity was comparable to that of the nitrogen ices covering Triton and Pluto's surfaces. In their second piece of research, the authors demonstrated how extrasolar objects with a composition comparable to that of Pluto and other Kuiper Belt objects could collide and cause the formation of nitrogen ice fragments of this type. According to their calculations, these collisions would result in the generation and expulsion into interstellar space of approximately 100 trillion objects, of which roughly half would be composed of water ice and the other half of nitrogen. This population would be sufficient to meet the statistical significance of ISOs required to provide an explanation for the discovery of Oumuamua. Equally as important was an object made of nitrogen would not form a tail as it approaches our sun, because there would be no water vapor or carbon to sublimate. This would prevent the formation of a tail. They concluded that the model is inaccurate by many orders of magnitude, and this was true even under the most optimistic assumptions that could be possibly made. In a nutshell, a star system would not have sufficient nitrogen ice to enable the existence of such a large population of exoplutos. This means that, statistically speaking, there simply cannot be enough ISOs composed of nitrogen to account for the fortunate detection of Oumuamua. When one takes into consideration the natural process by which cosmic rays erode ISOs, the model becomes even more implausible. The lifespan of ISOs is significantly shortened as a result of this process, contrary to what was previously believed, according to other research that was just recently published. Siraj and Loeb also cite research that argues that the hydrogen iceberg and nitrogen iceberg hypotheses are both riddled with significant flaws. The temperature requirements for the earlier theory render it impossible to be accurate, whereas the necessary formation efficiency does the same for the latter theory. In the end, they came to the conclusion that the mechanism for producing nitrogen ice fragments, that is, impacts on extrasolar Kuiper belt analogs, was just insufficient to create objects of the size of Oumuamua, and that it was also several orders of magnitude too low to produce a population of 1,014 objects. This nitrogen story was just not adding up, and it was clear that the Oumuamua mystery is far from solved, which should serve to further motivate the investigation of objects similar to Oumuamua in the years to come. And it's from this that we get the Galileo project, a project whose goal is to discover and characterize objects like Oumuamua, and ultimately to understand the nature of the objects themselves. What does this imply about Oumuamua and the more exotic explanation of its origin, namely that it may have been a solar sail used by extraterrestrial beings to travel through space? The most recent counter-argument paper indicates that the verdict is still out on Oumuamua, and there is still debate regarding which explanation is the most plausible. It's therefore a source of great good fortune that in the not-too-distant future, there will be opportunities for research that will provide additional limitations on ISOs. The Galileo Project is a non-profit research initiative that was founded by Professor Loeb and Frank H. Lockian, who is a visiting scholar at Harvard University and the chairman, president, and CEO of the Bruker Corporation. Amir Siraj serves as the Director of Interstellar Object Studies for this multinational and multi-institutional project, which is composed of volunteer experts from a variety of fields. They're collaborating in an effort to make the search for extraterrestrial intelligence and technological signatures more well-known in the general public. They're joined by astronomers and observatories from all over the world that are looking forward to the next few years when observatories of the next generation will become operational. Among these is the Vera C. Rubin Observatory, which was formerly known as the Large Synoptic Survey Telescope and is currently nearing completion of its construction in Chile. It's anticipated that it will begin operations sometime in 2023. This observatory will conduct a survey that will last for 10 years, during which time it will observe an estimated 37 billion galaxies and stars using its 8.4-meter or 27-foot mirror and its 3,200 megapixel camera. The Rubin Observatory will also conduct research into our solar system, and it will send out regular alerts regarding newly discovered objects, including an estimated 5 ISOs every month. Both NASA and the European Space Agency are currently working on developing missions that will soon rendezvous with ISOs in order to conduct in-depth research on them. If there's one thing on which the entirety of the astronomical community can be said to have reached a consensus, it is the idea that Oumuamua is representative of a previously undiscovered class of objects. The frequent passage of such objects through our solar system, along with the possibility that some of them will remain there, opens up a wealth of research possibilities for the future. What do you think, though? Do you believe that Oumuamua is just an uncovered part of science? Or do you think that it's some alien spaceship that was just checking in on us? Let us know your appreciated thoughts in the comments section below, and if you enjoyed this video, be sure to hit that subscribe button for more amazing content. We'll see you in the next video.